Integration day 2. We'll continue with U substitution, or some U substitution, but we're going to add an extra piece here. So today we're going to do definite integration. And you don't really even need to know that name, you just need to be able to recognize what to do. So just as a warm-up practice problem, just to get your brain back into integration mode, integrate that one. No U substitution even necessary. Antiderivative of x squared plus 7x, x squared plus 7 dx. So hopefully you got that as well. What we're going to do today is put some limits on this integration. So let's go from 1 to 2 of x squared plus 7 dx. Now there's a link here that we're not really going to focus on yet, but where have we seen those limits before? Or what did that mean when the antiderivative had limits on it? What's that? It was on the last test. You had some that looked like that. Okay, it was something about between the points 1 and 2. It meant the area between the points, between x equals 1 and x equals 2. That's right. That's still true. But I don't know, this is a parabola, but I don't know the formula for the area of a parabola. We don't learn that in geometry. So there's another meaning for this. So yes, it's area, but what it also means is, all right, so the antiderivative is the same, 1/3 x cubed plus 7x. But then here's how we handle the limits. If there aren't limits, then it's indefinite integration. Which really fits well with the area thing, right? Because if you don't know where you start and where you finish, how are you supposed to know what the area is? It's indefinite. But definite integration is when we have limits. That's what makes it definite. You may note that's a great question. It's not supposed to be plus c. Well, actually, it could be plus c. Let's put the plus c on there, and you'll see why in a moment why I left it off, and why you can leave it off from here on out. So we can put the plus c on at the end, because that's how we usually do it. And then this 1 and the 2 get sort of bumped to the end, because now we're going to use them. I guess I say we put them at the end because we've used the antiderivative. We've taken the antiderivative, so I don't need that symbol anymore. But I haven't used the 1 and the 2, so I put them at the end, and we're going to evaluate the antiderivative at the upper limit minus evaluate the antiderivative at the lower limit. Plug in the top minus plug in the bottom. Maybe that's an even easier way to say that. So if I plug in 2, that's 1/3 2 cubed plus 7 times 2 plus c minus, plug in the lower limit, 1/3 1 cubed plus 7 times 1 plus c. Guess that's a safe stop, but what's an easy thing that could cancel? the c's. And so that's why a lot of times with definite integration, like I did earlier, I left off the c, and you were right to call me on it, but the reason I left it off is every single time they end up canceling out. So you don't have to do the c. Although, if you're worried about forgetting it at some other point, there's nothing wrong with including it. Just make sure it goes away later. And then that is a safe stop, so yeah, why mess with it? Why worry about messing with the fractions and stuff? Let's just leave it alone.
This is minus.
That's always a minus right there.
Okay. I wasn't sure if I would just put that in a dash.
Always a minus. You're always doing the top limit minus the bottom limit. Now, we're not really worried about this yet, but that does tell me the area under the curve. So that's a big deal with calculus. We'll talk more about it later in the week. The idea that an antiderivative can tell you the area under a curve. Like, it doesn't really make, why would that work? Don't know, but it does, and that's a big deal with calculus. Right now, though, we're just worried about being able to take the antiderivative, plug in the top, minus plug in the bottom. Integral from pi over 4 to pi of x plus sine of x dx. Oh, let's pick on some people here. Make you famous as well when this video goes viral. Natalie, what's the antiderivative of x?
1/2 x.
Good. And Lauren, what's the antiderivative of sine? Good. Okay, now again, I'm slowing down here. We did the antiderivative, so I don't want to write the antiderivative sign. That's the mistake that freshmen make when you ask them the square root of 16 and they tell you that it's equal to 4, but they leave the square root sign on there. You're like, no, you use the square root, don't write it again. You antiderivative, don't write the antiderivative sign again. But we haven't used pi over 4 and pi, so let's put that at the end. And again, it's always the top one minus the bottom one. So let's plug in the top one. And there's lots of safe stopping going on here, or there can be, because I don't know what pi squared is. You can even safe stop cosine of pi. I hope you know what cosine of pi is, but you can safe stop that. So top limit minus bottom limit. So 1/2 pi over 4 squared minus cosine of pi over 4. Again, that is a safe stop. Calc Chat, of course, is going to go crazy with that. Multiple choice test would simplify that a little bit, but that is a safe stop. When you are forced to continue on and simplify that answer further, the biggest thing is be careful with the minus sign. That's why I try to always do like brackets, first limit minus brackets, second limit, so that I can see that minus minus is going to become a plus on that one. I mean, simple stuff, you know that, but sometimes it gets lost. Do one more of sort of free notes, and then we'll do a couple off the assignment together. Integral from 0 to 2 of x e to the x squared dx. So if that feels like we just jumped up in difficulty, you're correct. Because I don't know what the antiderivative of x e to the x squared is, but this could be a u substitution thing. So do you see a a good choice for what u could be? Well, we wouldn't do e to the x. We could do e to the x squared, but then, don't write this down because it's not right, then du would be e to the x squared times 2x dx. That's a lot going on. You sort of overshot what u should be. If we do x squared, that's a great pick because then what's du? 2x dx, and that's almost what we have. We can put a 2 there. So 1/2 antiderivative. Let's be careful here. So x squared was the u. So e to the u, and then 2x dx made the du. Alright, so I've got to remember what the antiderivative of e to the u is. Before we get to that point, I've intentionally left off those limits for now. Remember back earlier you said that this meant, like one of the first things we said was this was the area under this curve from x equals 0 to x equals 2. But I've switched it up now. This isn't x stuff anymore. This is u stuff. So if I put 0 and 2 right there, like the variables that are there, or the numbers that are there, need to match the variable at the end. So like this, the 2 and the 0, those are x values. So I don't feel like I can put 0 and 2 there anymore because these are supposed to be u values. So what could I do to figure out what goes there? Well, I know what u is in terms of x. So I could change my limits as well as changing the integrand. So when x is 0, u is 0. So that was an easy one. So I'm going to change my limits to be u limits as well. Like if you're changing to u, you got to change everything to u, and that includes the limits. Top limit, if x is 2, u is 4. That's a huge deal. People will get everything else right, but they'll leave the 0 and 2, and so they'll miss the problem because they were plugging x limits into a u substitution problem. All right, how about what's the antiderivative of e to the u? Been too long. This is our favorite one. The antiderivative of e to the u is e to the u. Still have the 1/2 out front. 0 and 4. And so now I can plug in 4 and plug in 0. So e to the 4th, minus e to the 0. That's a safe stop, but e to the 0 is 1, so 1/2 e to the 4th minus 1. So it's u substitution plus a little bit. Well, no, not plus a little bit. It's just more to the u substitution. So not only do you have to figure out the integrand, you've also got to change the limits to u things. The assignment is worksheet 31 that I'm about to pass out, but then we'll do a couple of those together as well. All right, so the assignment is this worksheet. Definite integrals. So that means upper and lower limits. with u substitution, so just note to self, that also means change the limits to u values as well. So we're kind of putting it all together with this worksheet. So let's look at number 3. So it's got A's in there, but that's okay. We can handle this. Nice if my camera would focus better than it's doing. That's as good as it gets. Come on. There we go. All right. Antiderivative 0 to a of x square root of a squared minus x squared. Any idea what u should be so that du might show up, or something like du might show up? By the way, a is a constant, so derivative of a squared will be 0, so I don't really have to worry about that part. You could let it be x squared, but that would be too simple. Let's make it a little bit more complicated. Let's make it all of that. So u is a squared minus x squared. Du then is, again, a squared is a constant. What's the derivative of a constant? 0. So it's tempting to say 2a dA or something like that, but it's a constant, so that's 0. So negative 2x dx. That's not bad. We almost have that. I can make that fix with a negative 2 in there and a negative 1/2 out front. And then all of this stuff is du. Antiderivative of u to the 1/2. That's not too bad. But don't put 0 to a in there. 0 to a is x values. I need to change those to u values. So I need to find u when I plug in 0 and u when I plug in a. So when I plug in 0, I get a squared. That means I'm going to replace the 0 with a squared. And I plug in a. Oh, this kind of gets weird because there's a's already there. But when I plug in this a, what do I get? 0. We can keep going, or we can make a fix right here if you want to make a fix. Or we could just keep going and not worry about it. Does that look, do those limits look unusual to anyone? They're backwards. Backwards meaning we usually like the lower number on the bottom. So if you want to switch them, that's fine. What price do you have to pay to switch them?
Add a negative.
Put a negative on them. So some people are just going to say, bah, who cares? I'm going to safe stop this anyway. Let's just roll on. And that's fine. Other people are going to be like, wait a minute. If I'm thinking moving left to right, and I really like the bottom one to be lower than the top one, some people want to switch them. So 0 to a squared. And this one actually works out well because if you add a negative, the price you pay to switch them, it cancels out the negative that's already there. So it's really a win-win for this one. Again, you don't have to do that though. You can leave them out of order and leave the negative there. All right, antiderivative of u to the 1/2 would be u to the 3/2. And what will the coefficient be to make that work? 2/3. And there's still a 1/2 out front. From 0 to a squared. So, okay, maybe to avoid some of the fraction confusion, I'm going to put the 1/3 out front, because the 2's cancel. And then I can just plug in a squared minus plug in 0 squared. So a squared to the 3/2 minus 0 to the 3/2. And yes, you lazy bums, that is a safe stop.
Okay, hold on. That was unfair.
You efficient bums.
Thank you.
You efficient, alert calculus students. How about that? So you went from lazy bums to efficient and alert. That's a safe stop. Multiple choice test. Power to a power, multiply the exponents. You would get a cubed, and then 0 would just be 0. So the most simplified version would be a cubed over 3. The most efficient version, I don't know if efficient's the right word. Easiest version would be to leave it alone and don't mess with anything. Putting a lot of stuff together today. Got to know derivatives. You got to be able to do backwards derivatives, and you have to know them well enough to do u substitutions. And by the way, don't forget to change the limits, and then top limit minus bottom limit. That's a lot of stuff going on. Let's see how far we can get with number 6. Yes. Yeah, x, a, and b. Well, a is just a constant, so that's why I wanted to do this one, because it gets confusing with constants in there. Any idea what we should let u be? Good, ax squared plus b. The constants don't bother us, because when we take their derivatives, that goes away, so du then is 2ax dx. That's okay. Not great, but okay. Meaning I can fix that. It's not my favorite fix, but it's not an awful fix. So 2a multiplied in there, and then a 1 over 2a out front. Antiderivative. Hold off on the limits, although I guess you could fix them right now. But I'm thinking u and du right now, so I'll get the limits in a minute. So 2ax dx, all that's du. And then what's the rest of the integrand? Yeah, u to the 1/2. I need to put my limits, or I need to figure out what my limits are. So if I plug in 1, this is kind of an annoying problem with all the a's and b's floating around. But if I plug in 1, what do I get for u? If I plug in 1 for x, a plus b, like a plus b, that seems weird. Yeah, I guess. If I plug in 0 for x, it would just be b. So I'm going from b to a plus b. At least the smaller one's on the bottom this time. Oh, this is the same integral we just did. U to the 3/2, the 2/3 out front, 1 over 2a still out front, and from b to a plus b. This one's going to be just kind of annoying. There's not going to be much we can do to simplify. 1 over 3a, a plus b to the 3/2 minus b to the 3/2. And so I did the ones with A's and B's in them because most people find those annoying. The rest of them, there aren't any A's and B's to worry about. As always, keep up with the homework because we keep adding. It's supposed to be just a little bit every day, but that piles up if you don't keep up.